Now I'll explain few concepts about number system. A number system is a fundamental concept in mathematics and it refers to the set of numbers we use to count, to measure and to perform calculations. There are different types of numbers. Numbers are usually denoted by digits 0, 1, 2, 3, 4, 5 up to 9, like that it goes. So, natural numbers, I'll explain some types of numbers first. First, natural numbers. Natural numbers are denoted by capital N. They are counting numbers. So, it starts from 1, 2, 3, 4 like that. It goes on continuously. Whole numbers includes all the counting numbers with 0. Whole number is always denoted by capital W. Next one, integers. Integers, we denote it by capital Z. It includes all the positive numbers, that is all the counting numbers, then negatives of that counting numbers, that is minus 1, minus 2, minus 3, minus 4 like that. Then 0 also will be included in integers. So integers includes all the positive numbers, all the negative numbers and 0. Then even numbers. Even numbers are just the multiples of 2. 2, 4, 6, 8, 10 like that it goes on. Then 0 also will be included in even numbers. Then odd number starts from 1. It increases by 2 only. 1 plus 2, 3. 3 plus 2, 5. 5 plus 2, 7 like that it goes on. Then prime numbers. Prime number has only two factors, the number and by itself. It is divisible by itself. It has only two factors, number and itself. See, I am taking number 2. It is divisible by 2 only. Suppose if you take number 4, it is divisible by 2 also. 4 you can write it as 2 2s are 4. So 4 is not a prime number. Prime number means it should be divisible by 1 and by itself. Apart from that, it should not have any other factors. If you take 6, we can write it as 2 3s are 6. No. So it is not a prime number. So prime numbers are numbers which are divisible by 1 and by itself. So 2, 3, 5, 7, 11 like that it goes on. Next, perfect square. A number multiplied by itself is said to be a perfect square. 2 square, that is 2 is multiplied by itself, that is 2 into 2, 4. Then 3 square, that is 3 into 3, 9. 9 is a perfect square. Suppose 17 square, 17 into 17, that is 289. So 289 is a perfect square. But square root of 289 is 17. Because when you multiply by 17, then only you will get 289, no? So, square root of 289 is 17. Again, square root of 9 is 3. Okay. Now, I'll do 1 or 2 problems based on these concepts. Now, this is one question from R.S. Agarwal book. Which of the following are prime numbers? That is the question. 4 numbers are given. First number is 241. You have to find out the square number which is greater than 241. So for that you should be thorough with all the perfect squares. 16 square is 256, which is greater than 241. So what is the square root of 256? That is 16. I wrote 16 is greater than square root of 241. First of all, you have to write like that. Then you should find out the prime numbers which are less than 16. So already I told you, no, prime number is the number which has only two factors, 1 and itself. So I am writing all the prime numbers less than 16. 2, 3, 5, 7, 11, 13. Then 17 is a prime number, but it is greater than 16. So I am stopping with that. So 241 is not divisible by any of these prime numbers. You should see whether 241 is divisible by these prime numbers. It is not divisible. So 241 itself is a prime number. Okay, let us try for the next number, 337. So you should again here also you have to find out the square number which is greater than 337. 19 19s are 361 which is greater than 337. So again I am writing 19 is greater than square root of 337. Now I am searching the prime numbers less than 90. I wrote 2, 3, 5, 7, 11, 13, 17. Now you should see whether 337 is divisible by these all the prime numbers. It is not divisible by all these prime numbers. So 337 itself is a prime number. Next you should do for 391. Now again you have to find out the nearest square greater than 391. That is 400 is the nearest square. Square root of 400 is 20. That 20 is greater than square root of 391. Now again you have to write all the prime numbers less than 20. I wrote all the prime numbers. Now you should see these prime numbers are the divisors of 391. 391 is divisible by 17. So 391 is not a prime number. Same process you should do for this. Finally, we are getting the answer as only 391 is not a prime number. Remaining all the three are prime numbers. That is the concept.